Welcome everyone to the Priva Academy live training session. My name is Brianna Parker and I am the marketing coordinator here at Priva North America. We want to thank you all for your participation today. We encourage you to ask questions throughout the session. Feel free to chime in if you have any comments as well. As always, we'd love to hear from you if you have suggestions or topics you'd like for us to cover in the future. Today, we'll be covering the I168 Curtain Control. Some of the topics that will be touched on today include shading, blackout, and energy curtains, curtain gapping, and cutting-edge strategies for managing curtain light emissions. There will be time for open questions as well at the end. As I mentioned before, you're welcome to ask questions as Chris is going through the demonstration, but for anything that we didn't touch on, there will be time to have those discussions as well. So feel free to unmute and chime in, or you can put your questions through in the chat and I'll be sure we work those into the training as well. We're all set to get started. This is Chris Androni. He is a Priva systems consultant here at Priva North America. Over to you, Chris.
Thanks, Brianna. Just want to thank everybody for joining the session today. I'm going to share my screen here. So like Brianna said, we're going to cover some curtain control strategies, and we're going to range on a different view. We're going to cover basically, we're not going to get too deep into the weeds on all the controls, but we're going to go over a bunch of different things, such as your I168 curtain control page, I162 energy curtains, I163 shading curtains, I161 blackout, I165 gapping, and then I207, which is our curtain emission strategy. We're going to touch all the basics on these different strategies. We're not going to get too deep into the weeds, but it should give you a good base on setting up these strategies, and we'll go through some theory, and then we'll also demo some of this stuff as well on our test server here. So a couple things we're considering when we are using curtains. We need to ask ourselves, what type of curtain are we using? Is it a shading curtain, energy curtain, or blackout curtain? Before we get started, we need to know a few things about the curtains and then also about the area that they cover. So first thing is, how big is the area that the curtains cover? This one's very important, not only for the curtains, but most of the Priva controls. We need to know how large the spaces are that we are controlling, whether it's curtains, heat, vent, any of those items. And it's very important for energy calculations, radiation savings calculations. So that's number one. Number two is, what are the radiation savings for these curtains? So in other words, how much light are we blocking when the curtains are pulled? And what is the energy savings for these curtains? In other words, how much energy are we saving when the curtains are closed in an energy curtain situation? These two items, they're readily available from most curtain providers. If we take a look here from our friends at Svensson, there's a couple different options here. I just kind of grabbed a few different examples here. So the Harmony 1315 OFR, that has a radiation savings of 20% and an energy savings of 15%. That would be a good example of a shading curtain. So we're saying when the shade's pulled, then we get an energy savings of 20%, or sorry, radiation savings of 20% and an energy savings of 15%. For the Harmony 3915 OE, radiation savings of 61% and an energy savings of 45%. That'd be a good example of more of an energy curtain. It's blocking more light and saving a little bit more energy, giving us an extra layer of insulation. And then the Obscura 10070FR WB plus B, that'd be a good example of a blackout curtain. So radiation savings 99.9%. If anybody's ever been in a greenhouse that's in blackout mode with a proper blackout curtain, yeah, you're blocking 99.9% of the light. And since those curtains are thicker, you get a little bit more energy savings as well at 70%. So that information, if I'm going to commission a curtain installation, that's going to be my first question. So yeah, number one is, how big is the area that we're covering? Number two, what is the radiation savings? And number three, what are the energy savings? I enter those percentages into the computer, and then when we're closing, opening the curtains, then the computer knows how to react accordingly as far as heat calculations, vent calculations, just to make sure that our climate's as stable as possible. So if we look at our curtain control page, number one is our I168 page curtain control, and that's where we can enter in some general settings for our curtain motors. On line 2, this one's very important. Typically, if someone calls and says, hey, my curtains they're staying open all the time, this is going to be my first question here. So by default, they come on none. If line 2 is set to none, then the curtain's going to remain open and the curtain control program is going to be deactivated. If we have it set to always, then the curtain drive is always released. So no matter what time of day, as long as we have one of our strategies open, the curtain's allowed to open and close. And then if we set it for clock, we're able to put a start time and an end time. In other words, we're saying, okay, the curtain is going to be able to work during these periods during the day. Line number 5, there's an option to put a fixed position in for a curtain. So if you say, okay, I want to keep this curtain set to 50% or whatever it may be for however long, you can set that fixed active. One thing to keep in mind when you're using that fixed active, if it's something that you're just going to temporarily override the setting, I would suggest to use the temporary settings, because once you have it set to fixed active and you turn that to yes, the curtain's going to go to whatever position you have in there and it's going to stay in that position. So even if one of the strategies is asking, say your energy strategy is asking for those curtains to close, if you have fixed active set to yes, the curtain's going to stay at whatever position you put there. So easy to forget. Oh, sorry. Thanks, Ryan. Line 7. Then line 20 and 21, max curtain position rainfall radar. If you're using our rain radar add-on to Priva Office, you're able to preemptively open the curtains, pull back the curtains all the way, just in case there is a threat of damaging the curtains in a rainstorm or storm condition. That's a good example for if you have curtains above the greenhouse on the outside, you can use that option as well. So I'm going to switch over to our demo just to show an example of this. So here's our I168 curtain control program. Again, release curtain. If I have that set to no, the curtain's not allowed to move. If I set it to clock, it's going to give me a start time and an end time. Our fixed active, if we turn that to yes, then it'll go to whatever position I have here, again on line 7, not line 5. So if I wanted to override the curtains to say 75%, I can type in a position here. It's going to stay there as long as this is set to yes until I turn it back to no. Once I turn it back to no, it's going to listen to whatever controls I have here. If I wanted to use the clock, I can say, okay, if I only want the curtains to be active during a period of time, say 8 a.m. to 8 p.m. for whatever reason, I can set those times in there. Whatever strategies we have active, as long as we're within these times, then the curtain's allowed to open and close. And then our always setting, which is probably most commonly used. Once you have that set to always, no matter what strategies are active, we're able to open and close the curtains based off of whatever strategy is calling for it. Like I said, for the fixed active, yeah, it's easy to set this on yes. So say you're temporarily testing a curtain, maybe overriding it just to check a position, or you want to check the installation. If you just set it on yes like this, yeah, it's easy to forget to turn it back. So always when you're overriding something temporarily, I always suggest to use a temporary setting here. If you click on the little triangle in the top left, you can say use temporary setting. I can set that to yes. And then say I wanted to have that activated till 6 p.m. I can click here. I can choose other compartments if I wanted to. If I just want this one, I can say set. It's going to turn my setting blue here. And then at 6 p.m. later on, it's going to activate back just as a safety that you can say, okay, I know that setting is going to change. Switch back here. That's our curtain control. page. So next page we're going to look at is our shading curtains, which is I163. We're going to take a look at shading curtain conditions, so how we can operate those shading curtains, shading curtain methods. And then we're going to take a look at I163.1 as well, so shading curtain influences, which are the deadbands and deviation sum. We don't only use that for the shading curtains, that's used in the energy curtain program as well, so it's very useful information for both strategies. So first, if we look at shading curtain conditions, we're going to ask ourselves, how do we want to operate our shading curtains? First one we can use is light. So the shading curtain closes based on the calculated radiation limit or PAR limit, if we have a PAR sensor. We can also look at temperature. So the shading curtain closes up to the set maximum curtain position based on the set greenhouse temperature limit. So if you're saying, okay, it's getting too hot in the greenhouse, I want to pull the shade to block some of that sunlight coming in, you can do that. Or you can use both. So if either light or temp conditions met, then the shading curtain closes. If we look at the first method, which is going to be fixed, we can set the curtain to operate on a fixed shading method. So based on the set temperature, radiation, or PAR level, the curtain closes to a set position. The curtain will open and close based on the set point, plus or minus a deadband. The curtain will also calculate a deviation sum to prevent the curtain from moving too frequently. And influences can be used to adjust the radiation limit as well. Our next method is I163, so shading method of range. The way that the range works is based off of the set radiation or PAR level the curtain is activated. The shading curtain, again, is going to use a deadband, a deviation sum like the fixed method to prevent too much movement. And then the curtain's going to modulate to a position set according to the light or temp level. The difference between these is once you use a fixed shading method, as soon as you hit your radiation limit, your PAR limit, or your temperature limit, the curtain's going to go to a set position and then it's going to stay there. The way that the range works is that once it hits a radiation limit, a PAR limit, or a temp limit, it's then going to use this table pictured here to figure out a position based off of how much sun or how much temperature you're actually getting inside that you want to block. So it gives you a little bit of modulating there, so it's not just going to a fixed position and then staying there. The last shading method is PAR. That's most commonly used when there are at least two curtains above each other. So one curtain, typically the bottom curtain, is going to be a diffuse curtain. It's going to diffuse the light, and the other curtain controls the amount of PAR under the curtain. So it kind of works similar to how the range works, but you're going to have a curtain on the bottom, which is a diffuse curtain. It's going to spread out light. And then the curtain on top, you're going to enter in a PAR level. The diffuse curtain stays shut, and then the upper curtain is going to modulate to maintain how much PAR you're getting down at your crop. So again, you need a diffuse curtain and then a PAR sensor inside. This one as well uses a deadband to prevent too much movement, deadband and a deviation sum to prevent too much movement. Switch over here and we'll do some examples. If we take a look at our shading curtain strategy, I'm just going to use this one here. So we'll just look at temperature for now. If we look at a shading method of fixed, give it a chance to adjust here. So what we can do here is we can set our start time and our end time. So again, if we said 8 a.m. here, our shading conditions temperature, our temperature limit. So say we're at 27, we say, okay, yeah, we want to pull the curtains. And then we have a max curtain position. Yeah, 95 is good. Then what's going to happen is during this time period, so 8 a.m. to 8 p.m., we're looking at temperature. If the temperature inside a compartment goes above 27, then the curtain immediately pulls to 95%. shouldn't say immediately, taking into effect the deadband and deviation sum, so not immediately, but when that's accumulated, it'll shut and then it'll go to 95% and stay at 95% until those conditions are no longer active. We have another line here, line 18. What that does is if the curtain decides, say your curtain's open and you're 30 minutes within the end time of that period, then the curtain's going to say, okay, I'm not going to bother closing because we're within 30 minutes of the end of the period. We go back to radiation here. And we change our range, our shading method to range. This one itself is looking at radiation sensor. We have a link to a PAR sensor on the weather station. What we can do here is we can set a PAR limit. This is the limit to which the shading strategy becomes active. Once we have this here, we can set our table accordingly. 200 micromoles, 300 micromoles. The way that the curtain is going to activate now is that as soon as we go above 800 micromoles, the shading curtain is going to go to its first position of 50%. When we're 100 micromoles above that, it's going to go to our second shading position of 65. When we go 200 above our PAR limit, so 1,000, it's going to go to our third shading limit. And then when we go 300 micromoles above our PAR limit, so 1,100, we're going to go fully closed at 100%. Anything in between these steps, the curtain's going to proportionally move based off of whatever we have set here. Again, we can set a max curtain position. So no matter what we put in here, we can limit and say, okay, I want to keep the curtains at least 5% open. And then again, we have an active before end time. You can also add in, if you wanted to adjust your PAR limit or your radiation limit, you can add in an extra influence here. So if you say, okay, I want to click on here and I can choose from our list of influences, you can link those together and then you can use whatever influence you have tied in back to fill out a table to adjust our PAR limit as well. And then if we look at our last shading method of PAR, again, most commonly used with a diffused curtain. Here we have a PAR limit. That's where the curtain's going to activate. And then we're able to set a number for PAR below curtain. So if we're trying to maintain 1,000 micromoles below the curtain, the PAR limit is where your diffuse curtain is going to close. And then your PAR below curtain, the curtain above the diffuse curtain is going to modulate to try and maintain our 1,000 micromoles. Again, we can say if we want to keep the curtain gapped for a little bit of airflow, we can give a max curtain position here. And then we also have an active before end time as well. For our shading curtain influence tab, that's where we are going to make our adjustments for deadband temperature or deadband radiation and our deviation sums as well. So deadbands and deviation sums are used to ensure the curtain control is not reacting too quickly or too erratically to ensure the climate stays as stable as possible. If you have a situation where you have no deadbands and no deviation sums, then sometimes what will happen is the curtain's going to open, close, especially on a day where you have lots of rolling clouds. Somebody calls me and says, hey, my curtains are moving too much. I want to limit that because it's going to stabilize the climate inside. And then it's also going to reduce the wear and tear on our equipment. Then I come to this page and I adjust our influences. So if we take a look at the dead bands are kind of like a dead zone where the control is not going to be activated. So if we take a look here, we have a dead band for temperature and a dead band for radiation. And then we have two charts here. So within the dead bands for temperature and within the dead bands for radiation, we have our temperature limits and our PAR limits, which we set on our I163 page. When the measured value for either temperature or radiation is operating within our dead bands, the control is not going to be activated. The only time that the control is activated is until it goes past the set point plus or minus the dead band. If we look at our deviation sums, the deviation sums is the difference between the measured and calculated influence. The addition takes place once every minute. So once the calculated value exceeds the set deviation sum, the control is activated. While you're calculating your deviation sum, if the measured value reaches the dead band, so if it goes back within that dead band or that dead zone, then the deviation sum counter resets and begins counting from 0. A quick example of how the dead band and the deviation sum works. If we take a look at this example, we have a set point of 24 degrees Celsius. We have our dead band temperature set to 1 degree. So the control is going to activate at 25 degrees Celsius. And then we have a deviation sum curtain close of 10 degrees Celsius. So if we look at this chart down here, it goes minute by minute. So along the top here, we're counting minutes. If we have a measured temperature of 25, so that's our set point plus our dead band, we don't have a difference there yet. So the control starts to activate. After minute number 2, if we have a measured temp of 2 degrees Celsius, we're going to have a difference of 2 degrees. So we're going to say, okay, we're going to add that onto the deviation sum. After minute 3, if our measured temperature is 25.5, we have a difference of 1.5. So the difference is going to be between the set point and your measured. That's going to add on as well. So that's going to go to 3.5. After minute 4, if we go up to 27 degrees Celsius, we have a difference of 3. That gets added on as well. Minute 5, we're at 26, which is a difference of 2 degrees. That goes up to 8.5. Then suddenly, if we get a drop in temperature to 23.5, we're back within that dead band. So there is no difference there. And the deviation sum resets back down to 0. So in that case, the curtain's not going to close. Then after minute 7, if the temperature goes back up to 27, we have a difference of 3. Then we have a deviation sum of 3. After minute 8, we're at 28. We have a difference of 4 that gets added onto the deviation sum as well. And then finally at minute 9, if we stay at 28, there's a difference of 4 degrees as well. We're at 11, we've exceeded our deviation sum curtain close. And then the curtain's allowed to close. So if we take a look at that page, there's some helpful things on there. It's a little bit, when you first look at it, it's a little bit, there's a lot to it, but once you break it down, it's not too difficult. So if you look at our influences tab, we have our dead band. Yeah, in this case, it's PAR because we had it set to PAR. Our PAR deviation sum open, close, and there's a couple other influences here. But the thing that I wanted to point out down here is, so we've switched back to temperature. So if we look at our dead band of 1, our deviation sums of 10. Yeah, a nice thing that we have here is per period, we have a calculated deviation sum temperature. So if we have our strategy in That's going to activate the curtain. And we want to get a look on how the deviation sum is being calculated. We can come to the shading influences, so I163.1 page. And as the deviation sum is being calculated, it's going to display it here. So our deviation sum right now is -10. If we get into a situation that we need the curtain to close, minute after minute, it's going to start calculating here. So you're going to get a good idea of what's going on as far as your curtain closing. Going to switch back here. And that's it for the shading curtains. Again, like I said, we're just going to kind of touch the basic things on here as far as each of these strategies. We can get really into the weeds and cover a lot of content, but I just wanted to cover kind of the basics for each of these strategies. Next thing we'll look at is our energy curtain strategy. So that's page I162. We're also going to look at I162.4, which is our allocate energy curtain page. I162.2, our energy curtain control. Again, deadbands and deviation sums works identical to the shading curtain strategy. And again, all it does is just kind of smooths everything out and makes sure that the curtains operate in a smooth operation. And then I162.1, our energy step control, and that's for stepping the curtains open, close in the morning or at night, just to make sure that we have a stable climate. So if we take a look at our I162 page, our energy curtain strategy, a couple settings on here. Line 2 up at the top there is our energy curtain setting. A couple different things here that you can use. Automatic is probably 99% of the time what it's going to be set to. So the control is going to be activated on strategy. So whatever strategy you have set in the I162 page, as long as you have line 2 up at the top here set to automatic, it's allowed to listen to whatever the strategy is telling you to do. If you have a situation where you want to override the curtains, again, yeah, if it's only temporarily, I would suggest to use a temporary setting, but there's a couple options here for you. You can use open or close. What that's going to do is it's going to open or close the curtains using the step control program. We're going to cover the step control program in a few slides here. And then you can also use direct open, direct close, and that's going to override skipping the step control. For line 2, I always recommend to use it sparingly and only in situations where you're going to test it, or if the curtain's going to be closed, if you're closing down a compartment and you want to close the energy curtain for a set amount of time, you can use it there. Again, always with overrides, you got to be careful that you remember to turn it back, because if you leave it in open or closed or direct open and close, once it closes or opens, it's going to stay there until you turn it back to automatic. So of course, when you're operating a greenhouse, running a greenhouse, lots and lots of things on the go, so it's easy to forget those things. So always be mindful of using that, because once you set it to open or close, it's going to stay there. So say on a cold winter day, during the day, you want to override it open for whatever reason. If you forget to turn it back, then the curtain's not going to close at night if you don't switch it back to automatic. Line number 9, our method curtain. There's a couple different things you can use there as well. So auto. Once you have it set to auto, the curtain's allowed to be controlled open or close based off of the settings. So whatever settings you enter in, if the settings become true, then the curtain can close. If those settings are no longer true, then the curtain can open. If you use auto open or close, what that's going to do is the curtain is going to be controlled once based off of the settings, either open or close, whatever you have it set to, and then it's going to stay there for the rest of the period. So basically what you're saying is you're going to give it one action, either open or closed. Example, if you want to close the curtain for the night, but you want it to close on its own based off the automatic settings, you can set it to auto close. It's going to wait. Once those settings become true for the curtain to close, then it'll close and it'll stay closed for the remainder of that period. And then our last selection is open or close. And basically what that does, it works like a time clock. So if you set open or close for method curtain, your settings are going to disappear altogether, and the curtain's going to stay open or closed for the duration of that period. And then again, line number 25, most of the strategies have it, but the active before end time, if the control is activated within the set time to the end of the period, then the control is not performed. So we'll switch back here to our demo again. Take a look here. So energy curtain, if we look here, again, our open and close override, it's going to open or close the curtains with the step control. And then direct open, direct close, and it's just going to close that, ignoring or open, ignoring the step control program. Periods here. This strategy is a little bit different. You can modify the number of periods. We're going to hit that in a second. But again, start time, you can set here. The end time of the current period is the start time of the next period. And then here's your method curtains. So if you wanted to use open or close, if I set this to open, and change that to auto, what it does is it gets rid of our settings altogether. So what we're saying is in between 7 a.m. and 10 a.m. in this case, the curtain's going to go open and it's going to stay open. If we set it to auto, of course, all of the settings that we've allocated there are going to be active. And then same thing with auto open, auto close. If we set something up like something like this, we can say do a daytime period and a nighttime period, and we can put our settings in here. So at 7 a.m., if we have that set to auto open, then it's going to wait until our settings are activated here. So if we say, okay, we want a radiation limit higher than 200, and we want the outside temperature to be higher than 5 degrees. Once those settings become true, then the curtain's allowed to open. Of course, it's going to open using the step control program, and it's going to stay open for the rest of the period. If it gets dark again for whatever reason and the outside temperature drops, since it's set to auto open, it's only allowed that one move. So it's going to just open, it's going to stay open. Again, if we say, okay, yeah, at 5 o'clock, I want to put some settings in here, or it may be, we can say auto close. So once the curtain's open during the day, anytime after 5 o'clock, the computer is going to watch these settings. It's going to wait until those settings become true. And then since it's set to auto close, once the settings become true, it's going to step closed, and then it's going to stay closed for the rest of that period. Back to our PowerPoint here. Next thing we're going to look at is I162.4. So we're going to ask ourselves, what conditions can I use to close the energy curtains? There's a big list here that we can use. We're just going to kind of skim over them. What I mentioned before about the energy curtain program works a little bit differently as far as the strategies go. On line 15, you're able to choose the number of periods, which is very nice. So if you just want to have a simple daytime and a nighttime period, you can put 2 periods in there and it's going to clean it up a little bit. Line 16, you can use radiation. Line 17, you can use radiation sum. So radiation sum keep open. So if you have a radiation sum you have in mind, that once you hit that, the curtain will remain open, you can use that. Line 18 is the opposite, radiation sum close. So if you want to use a radiation sum to close the curtain for the rest of the day, you can use that. If you have an irradiation sensor installed on your weather station, you can use line 19. Once you activate that, you can use your energy curtains. For the outside temperature, you're able to look at an absolute reading. So if you wanted to look directly at outside temperature, you can use absolute. If you wanted to use relative, that compares the outside temperature to the calculated heating temperature. Line 21, Gives you the ability to release weather influences on the outside temperature. So that'll give you access to page I162.2. What that does, you're able to add influences to outside temperatures. So if you wanted to change your outside temperature limit based off of the wind speed or any other weather conditions that you want to use, you can do that. Line 22, release temperature difference below above curtain. If you have a situation where you have an excessively large temperature difference between the measurement above the curtain and below the curtain, you can use that. Of course, you need to have a measurement above the curtain installed. And then a couple other things here, release multiple delays. So if you wanted to change how the curtains react to different dead bands and deviation sums for different parts of the day, you can use that. Line 24, you can use the water temperature as an influence. If you want to use that water temperature influence, you can go to page I162.4 at the top. There is a table to fill out to activate it. And then as well, you can use the heat demand on line 25, and all that does is it gives you a kilowatt value to operate the control based off of. So again, back to our demo here. Once we go to page I162.4, yeah, this is something that I find really useful. So if I change my desired number of periods to 2, and I go back to my strategy here, if I wanted to just use a daytime and nighttime period, it simplifies it. You say, okay, yeah, I know period 1 is my daytime, period 2 is my nighttime. If you go back to your allocate tab, highlight over top, you can use up to 6 periods as well. So once we change that, go back to our strategy, the other 4 periods are released there and you're able to fill them out if you want to. I find that one really useful. It's nice to kind of simplify things if you want to just keep it nice and simple. So as you go, you can enable these influences here if you want. Say we wanted to use our water temperature influence. We can highlight that here. And all we have to do is fill out which compartment that refers to if we wanted to. So if we wanted to look at compartment number 1, mixing valve group number 1, we can fill that out here. Once it's filled out correctly, it's going to say connected here, and then it's going to give you a measured value. So your calculated water temperature, and it's going to give you a calculated heat demand in watts per meter squared. If we do something where we put a compartment here that doesn't exist. So if we say compartment 10, we're going to get an error here and we're going to say wrong connection. So if we have that, then we're not able to use that water temperature influence. One other setting that I didn't have on the PowerPoint as well, is there is a release force flows low outside temperature. What that does, maybe not as useful for our friends in warmer climates, but in colder climates where it gets really cold, when you use that setting, what it does is it releases line number 3, and that's going to be your kind of absolute. It goes for all of the zones, goes globally throughout the whole time period. And basically what we're saying here is, this one's set in Celsius. So if we say, okay, if the outside temperature goes below -20 Celsius, then no matter what period it is, just close the curtain all the way. That's the point where we're saying, okay, yeah, it's the coldest day of the year. We can't keep up. We need to do something about this. And what it's going to do is it's going to close it all the way, and then it's going to close it. Okay, we'll switch back here. Yeah, if you look at this table here, lots and lots of influences. I use this all the time. And if we ask ourselves, how can I keep track of all these influences? So if you have a bunch of influences there that we're using, and we want to keep track of it, there's a nice table in the manual that says I162 energy curtain strategy. So if we hit F1, it's going to bring up our strategy here. If we click on the energy tab, then what it's going to do is it's going to bring up a table here. So if we click on energy, it'll bring up a table here. And all it is a nice flow chart to say, okay, clock condition valid, yes. Is the outside temperature curtain force closed? Is that activated? Are we using any other influences? So you can go through this table in case you have a situation where you say, okay, yeah, the curtain should be closed right now, but it's not. Why is that? You can kind of troubleshoot through here and say, okay, am I using this condition? Am I using this condition? And it kind of helps you troubleshoot that way. So I always find this very useful. Again, if you hit F1 on your I162 page, there's a thing that comes up at the top, and it says a graphic of this is shown in energy. You can click there and it's going to bring up this table. I162.2, we're not going to get too deep into that one. Again, just our deadbands and our deviation sums for all of the different influences that we use. Works the same way, doesn't operate within the deadband, and then calculates our deviation sum open, deviation sum closed throughout. Another thing we need to ask is what happens when we open or close the energy curtains. So if we're using an energy curtain, we have to keep in mind that an added layer of energy savings is added to the zone that we're covering. One thing we need to do is the heat needs to compensate accordingly. And we also need to monitor the inside and outside conditions to make sure that the climate stays stable as possible. Good example of this is a cold day. If we want to open the curtains, a couple things need to happen. So first thing is the energy curtains need to open. We need to ask how much energy savings are we getting from the curtains? So that's our spec that we're getting from our curtain provider. How much area are we covering? And what are the outside conditions? Second thing that we're going to do is once the curtains need to open, we need to adjust our heating system. So what the heating system is going to do is it's going to anticipate the curtain opening. We need to look at how cold it is above the curtain. We're either going to look at a sensor installed above the curtain or outside temperature. And then how much time do we need to adjust? Once the heating system adjusts, then the curtain's going to start opening. And the way that's going to work is the curtain cracks open slowly to allow the heating to compensate for the cold air above the curtain. And then the curtain's going to wait and watch to see the inside and outside conditions to decide how quickly the curtain can open to maintain a stable climate. The way we do that is with our I162 energy step control. So this works both for the curtains opening and the curtains closing. First thing we're going to look at is line 2, and that's the temperature difference under/above directly open. If there is a temp sensor above the curtain, if the difference between either the calculated temp or the measured temp is within that range, then the curtain step control program is going to skip completely. Line number 3, range temperature difference, slow or fast. That's going to be your temperature settings determining if we use fast or slow moves. Line number 4, our step factor slow fast. So depending on what we're using as far as temperature difference, slow fast, it's going to determine the steps the curtains will take. So that's in a percentage. So example on this one here, 25%. If we're using the slow range, the steps are going to be increased by 25% every time we make a move. Whereas if we're using the fast, we're going to double it essentially by using 100% as a multiplication factor. Line number 5, waiting time, step min and max. So that's the steps. How long are we going to wait in between curtain movements? Line number 6, first step and step control. This example, we're set to 2 and 70. So when that energy curtain decides to start opening, our first step is going to be 2%. Once we calculate anything above 70% open, then the curtain is going to control fully open. If we were to look at our first step control, say we're using our fast of 100%, our first step is going to be 2%, our second step is going to be 4%, our third step is going to be 8%, and then the curtain will keep opening from there. Line 7 is going to be how much time we're going to give the heating system to adjust based off of our range temperature difference, slow and fast. And then line number 8 is min curtain change time adjust heating. So any changes less than that are going to be performed without a delay. So that's any change in curtain position. Anything more than that will have a delay. And then line number 9, we have a dry position / duration after opening. So what we can do there is when we have a lot of humidity above the curtain and that curtain has a lot of condensation on it, what happens is we control the curtain all the way all the way open. The curtain's going to open all the way and then it's going to act like kind of wringing out a towel. So if you have a lot of moisture on top, the curtain opens all the way, opens and then bunches up nice and tight. Then what happens is you'll get a line of drips across that curtain. What we can do here is we can set a dry position. So right now we have 10% and 30 minutes. What's going to happen is if we calculate the curtain to go 10% or more, so 10% curtain position, it's going to stop there and it's going to stay there for 30 minutes. So it gives the curtain a chance to dry out. If we go back here to our demo to take a look. Take a look here. I only covered the open on the strategy, but the close works the same way, just in the opposite. So we have our temperature difference under, above, directly open. So if the difference between the heating temp and the measured temp is less than that, then we're going to say, okay, skip the program. And then we have our range temperature difference, slow, fast here. Step factors, waiting time. So you can set that accordingly. More often than not, I'll set this and I'll leave the default values in here and then only adjust it if there is any issues. Maybe the curtain's opening too quickly or too slowly. We can adjust that accordingly. Switch back here. Next thing we'll look at is our blackout curtain strategy. With the blackout curtain strategy, that's going to be found on page I161. And then we can gap the blackout curtains with an extra curtain gap on I161.2. So using the blackout curtains, we can set them 2 different methods. First method we're going to look at is blackout time. So if we have a set time that we want the blackout curtains, say, okay, at this time we want 12 hours of blackout, or in this case for the settings here, we have 15 hours. We can set that here. So we change our method to blackout time. Line number 3 is going to be our start time. So we're saying, okay, at 11 o'clock, I want the blackout time to start. Line number 5 is where we're going to set our amount of time that we want that blackout to last for. Lines 6 and 7 we can use to say, okay, if our radiation is higher than this setting, we're going to delay our blackout period. Or if our outside temperature is higher than this setting, we're going to delay our blackout period as well. Line number 8 is our delay time. So if any of these conditions become true, then we're going to delay the blackout by this amount of time. And then line number 9, we're going to give the option to open our curtain in a dark period. So if we say, okay, I want a certain amount of blackout time. Once we have that set amount of blackout time, are we allowed to open the curtain when we're sure that it's completely dark outside? We call it twilight time. With those settings, we have line 10, twilight time, sunrise, sunset. So the sunset time, it's the time after the sunset that the blackout's not permitted. So in this case, it's set for an hour. And then twilight time, sunrise. So that's the time before sunrise that the blackout is not permitted. So we're saying, okay, yes, we're allowed to open the curtain in a dark period when we're sure it's dark outside. We're going to count our twilight time 30 minutes before sunrise. That's going to refer to our sunrise sunset times on page M4, our weather overview. And then also we're going to say, okay, an hour after sunset, the curtain's not allowed to open as well, because we might still have a little bit of sunlight in there. Then line number 11, we have a dark limit and delay time. So we're saying, okay, our dark limit is set to 1. We need to be lower than 1 watts per meter squared for more than 30 minutes for that dark period to kick in. The benefit of using your dark period is to say, okay, yeah, I'm 100% sure that we're going to get no light coming in because it's nighttime, it's dark outside. If you have the blackout curtains closed, you're going to get that extra layer of energy savings, and then yeah, it could lead to maybe high humidity or high temperature in there. So during the dark time, you can say, okay, yeah, open the curtains because we know it's going to be dark outside. Then we don't have those issues. If we use line number 2, if we set that to clock, the way that's going to work is the curtain's controlled as a blackout curtain during the set times. And then all of the other settings operate similar to the blackout time method. Switch back here. So if we look at our blackout curtain strategy, if we turn it off completely, that disables the blackout curtain strategy. If we set a blackout time, we have a start time here. That's where the blackout's going to start. Then we can set our time here. So if we're looking for 12 hours of darkness, we can set that here. And then again, we can set our postpone limit. So if we say, okay, if our radiation is higher than 1000 watts per meter squared, or our outside temperature is higher than 20 degrees Celsius, then delay for 1 hour. And then here's where we set our open curtain and dark period times here. So we have our twilight time, sunrise, so 30 minutes before sunrise, and then 1 hour after sunset. And here's where we set our dark limit and delay time. So we have to be lower than 1 watts per meter squared. So no sunlight for more than 30 minutes. And then our dark period can be activated. The only difference for our clock method is when we change that to clock, we get a start time and an end time here. So if we're looking for at 12 hours of darkness, we can say eight to 8, and then that can be activated accordingly. If we get in a situation like I had talked about, we close those curtains, those blackout curtains tend to be a little bit thicker. Once we have those closed during a blackout time, then we're going to get some, maybe a buildup of humidity and a buildup of heat. We can use our gapping program for our blackout curtain strategy. That's called Extra Gap. That's located on page I161.2. Again, we can set a release for the extra gapping. So if we set as a clock, we're going to get a start time and an end time. We're going to say, okay, the gap for the blackout curtains can operate between these set times. Line number 4 is number of extra gaps per day. So that's going to be the total number of times the curtain can gap during a 24-hour period. So what we're saying here is, okay, we can gap. We don't want to gap too much because we might get a little bit extra radiation coming in. You can say, okay, I only want 10 gaps throughout the day. And then line number 5 is the condition on which you gap on. So you can choose between temperature, humidity, or both to gap the curtains. And then lines 6 and 7, either our temperature or our humidity can be used to dictate the gap. Line number 8 is waiting time gap blocked. So once we do a gap, so if we're saying, okay, we can do 10 gaps throughout the day, whether we're set on clock or always. Once we finish that gap, we can say, okay, we're going to wait an hour before the next gap. And then line number 9 is how long that gap's going to be active. Of course, we're using the blackout curtains to mitigate radiation. If we're mitigating the radiation, we're saying, okay, we don't want to gap too much, then we can limit the duration time for those gaps. Take a look at the gapping strategy for the blackout curtains. And here's where we can set, if we have none, it'll turn the gap off completely. We can set it to always. That means that no matter what time it is, we can gap the blackout curtains. Or if we wanted to set it during a set amount of time, we can set a clock here, and then it'll give us a start time and end time. We have a number of gaps per day. So if we say, okay, we're going to allow the curtains to gap 15 times, we want an interval of, you can put in an hour 30 maybe, and then the duration time. So if we want the gaps to last 2 minutes to gap 0.2, it's going to gap there. And then the gaps are going to be determined by line 6. So we're saying, okay, if we're 2 degrees above our calculated heating temperature, then we're going to gap 5%. Same thing if we switch it to humidity, it'll give us a table to gap based on humidity. If we're not using the gapping program, we can also use the regular, if we're not using the blackout gap or the blackout program, and we need to gap the curtains, we have another gap strategy on I165. So that's the situation where our energy curtains are closed for the night. If we get a buildup of humidity or high temperature, we can gap with that as well. So we can control that curtain gap. It's on page I165. It can be controlled by range or steps. There's 2 different methods for those. If we look at page I165 gap strategy, and we're going to use the range gap control, we can use line 7. This goes for both temperature and humidity. We have line 7, so our minimum temperature gap. Line 8, we have our maximum temperature gap. So we're going to say, okay, we can gap 2% up to 12%. Line 9 is going to be our temperature gap method. Again, we can set that to absolute or relative. If we use relatives, that's going to be the temperature gap based on the difference between the measured greenhouse temperature and the calculated heating temperature. If we use absolute, the gap works based on the measured greenhouse temperature alone. And then line 12 and 13 is going to be our range temperature gap absolute, start and end. And then line 14 and 15, if we're using our relative gapping, so comparing the calculated heating temperature to the measured greenhouse temperature, that'll show up on line 14 and 15. So if we look at these settings here, we're saying, okay, the curtain can gap from 2% to 12%. So that's going to be a 2% to 12% opening while the curtains are closed. And that range is going to operate between, it's kind of a tight range here that's set, but it's going to operate in a range of 29 to 30 degrees Celsius. Same thing for the humidity gap. It's just going to work based off of humidity. You're going to set a minimum humidity gap and a maximum humidity gap, and then you're going to set a range for start and end, and it'll operate proportionally in between there. Same thing with your relative, still going to refer to our minimum temperature gap and our maximum temperature gap of 2 and 12, but this time we're going to compare our measured temperature to our calculated heating temperature. If we use a gap control method of steps, you're still going to give it some range to work within, but then the computer is going to decide how much it needs to gap based off of the difference of your set point. So line 7 and line 8, you're going to still have your minimum temperature gap and your maximum temperature gap. And then line 9, again, you're going to set your relative or absolute temperature gap method. And then on line 10, you're going to set your temperature limit absolute. And then 11, you're going to set your relative temperature to which the gap started as well. Well, that steps program is activated. The control steps are going to be determined by the difference between the calculated limit relative or absolute and the measured relative or absolute temps. So basically what you're doing with the gap strategy here when you're operating on gaps or steps is that you're letting the computer decide how much it's going to gap, but you're still giving it a range. But once we flip back here and we go to our gapping program, again, humidity works exactly the same as the temperature gap. But line number 1 here, we have the options here to operate on a range or steps. So if we set it for range, we have a start time and an end time for both the temperature and humidity. And then here's where we set our options. So we can set a minimum or maximum. So say if I said, okay, I want a gap from 5% to 15%, and I can choose whether to use relative or absolute here. So if I say I want to use absolute, I'll switch that here for me. Then I can say, okay, if I get above 25 degrees Celsius up to 30, I want a gap from 5% opening to 15% opening. Same thing down here with the humidity. We have a minimum humidity gap, but a maximum humidity gap. So if I say, okay, I want a gap from 2 to 10, I can use the range humidity start. So if it goes above 60, I can set that. And then I have a range humidity end as well. So our 2 to 10% gap opening is going to work from 60 to 80. Also here with the humidity gap, there is a temperature influence that you can use as well. So you can say, okay, operate based off of a temperature influence to make sure that we don't drop too far in temperature if we're trying to maintain a certain humidity inside. And that is our gapping program. One last topic we'll touch on here is our light emission strategy. I have a nice picture here. In the Leamington area in Ontario and some other areas around the world, sometimes it's by law that if you're running lights, that you need to make sure you have blackout curtains or you get this effect. And they call it light abatement or light pollution. With the curtains, we have the ability to tie them to our I207 page, our light emission strategy. So if we look at our light emission strategy, it's a pretty straightforward strategy. And all we're doing here is on I207.4, we have a light emission allocation page, and we can say, we can look at the lighting programs, whether it's a switching light or a modulating light program, and then we can link certain curtains to those strategies. And all we're saying here is if, example here, switching light, so on-off lights, number 1, if those activate, we want curtain 1 in compartment 1 and curtain 2 in compartment 1. We want those to follow our emission strategy for there. As far as the actual light emission strategy goes, you have your periods. So you have your 6 periods. You have a start time and you have an end time for each period. And then all you need is a maximum light emission setting. So right now we're saying between 6:17 and 1 a.m., our maximum light emission 0, meaning that 0% of the light that's coming from the greenhouse can be emitted. So if we move over to that strategy, and we look at our light emission, first thing we need to check is our allocate curtain page. We pull out that table, then all we need to do here is we can choose, okay, switching light program 1. We want all of compartment 1 to listen to that one. Switching light compartment 2. We're going to link to compartment 2 and make our links accordingly. Maybe say like this. Then we can click OK. And then on our strategy, this is going to be a global strategy for all of those curtains that we have linked on this page. And we can set up different time periods. So if we say, okay, from 6 to 10, we're allowed to emit 0% of our light emission. If we wanted to open up another strategy here, then say from 10 to 4 in the morning, if we put a 5 in here, what that's going to do is it's going to allow the curtains to stay at least 5% open. So if the curtains are closed according to our table here, any of those curtains linked from 6 p.m. to 10 p.m., they're going to stay closed all the way. Any of those curtains that are closed from 10 to 4 a.m., they're allowed to emit 5% of the light, meaning that they're going to be at a position of 95%. So this is a nice strategy to ensure that, yeah, as long as those lights are activated, then the curtains will be closed. And that is all I had. Are there any questions?
Okay, looks like that's it. That's everything, Chris. So we hope that you've learned something new and are able to walk away with a better understanding of how Priva can help your clients optimize your strategies. We know Chris covered a lot of information today. There will be a recording of the session available in the Priva Academy starting in the next 1 to 2 weeks so that you can go back and review any information. If anybody wanted to revisit some topics discussed, or if you have any unanswered questions, or you just want to talk to us, always feel free to reach out as well. We're always happy to connect with our customers and our partners, and would also appreciate feedback on the live training sessions. Again, if you have any suggestions or certain topics you want to see covered in future training sessions, please let us know. You can put that right into the chat or also message us later on, and we'll be sure to review those suggestions. Chris, is there anything else that you'd like to add?
No, that's it. Yeah, just if there's any follow-up questions later on, feel free to reach out. We're always there for any questions, no matter what they are. And yeah, thanks for joining.
Fantastic. Okay, thank you everyone again for being here with us today and supporting Priva. Wish you all the best for the rest of your week and hope to be in touch again soon. Thank you.
Thank you.